Today we are going to learn the experiment of study of CRO and function generator. So study of CRO and function generator and how to measure the voltage and frequency on CRO. So this is CRO. We can see there are so many functions, so many buttons are there. So this button is to reduce the signal frequency to 10 times. We will see shortly. This when we press this button, so internal time generator will be detached and we will provide the two independent signal waveform externally. This is used to plot the Lissajous pattern. We will see later on. This is channel number 2. So when we unpress, so this is showing channel number 1 because this is dual channel, so it will be showing two channels. So when we press it, so it will show double channel number 2. When we unpress it, it will show channel number 1. This is mono and dual. So this is mono and dual. So when we unpress it, so this will show mono channel and single channel. When we press it, it will show two channels. So there are two channels. So this is vertical direction of one channel. This is vertical direction of two channels. Second channel. Now these are the Y shift and X shift. This is Y shift. So Y shift of channel number 1. So we can change the same signal waveform in vertical direction for channel number 1, and through this shift Y shift we can change the vertical direction of channel number 2. Per division, and this is time per division. So from this voltage per division we can change the number of voltage per division of the input signal, and from this time per division we can change the internal time generator. We'll see shortly how to change it and how to measure it. This is signal generator. So this is also having two outputs. So this is channel number 1, this is channel number 2. So we can take two output from the signal generator. So when we press it, so output will be coming. When we press it, output will be coming. Now there are various signal waveform from this signal generator we can obtain. So this is channel number 1. This is sine wave. So when we connect it, this to the input of the CRO, so this will be connecting like this. It should show the signal. So this is signal. We can just reduce it. So it has been reduced. Okay. So now it is showing the sinusoidal waveform, which is given through this signal generator from channel number 1. Now the frequency, this is frequency. We can change the frequency. So from this we can change the frequency. So we have to go to the frequency tab, and then we can change the frequency here. When we change it, the output will change. So this is channel number 1. So output will change here also. You can see the output is changing, the frequency is changing as we change the frequency here. So frequency is 1 kilohertz. So when we change, this is the output. When we change the frequency to 2 kilohertz, the frequency is some exaggerated. So when we increase it, so frequency will be exaggerated here. Likewise, we can change the frequency. We can also change the different type of waveform through this CRO. So we can change the waveform. This is like a square wave. So now it will be showing a square wave. So this is square wave. We can also change the frequency like this. So this is changing frequency. There are some other signal also. This is called ramp signal. So we can see. So this is a ramp signal. So as we press it, so it will show ramp signal. So this is showing ramp signal. So frequency of this ramp signal we can also change from here. This one is pulse signal. So this is a pulse signal. So different type of waveform we can obtain from this function generator. So this is for channel number 1. Likewise for channel number 2 also we can obtain. So as we connect to this channel number 2, so this will be going to channel number 2. So now this is coming to channel number 2. So we have to change it here, channel number 2. So now we can see this is connected. So this is the channel number 2 position. So we can also change the frequency. You can see if we change the frequency, this is 1 kilohertz, this is again 2 kilohertz. So frequency is changing again for channel number 2 like this. So we can also change the different type of waveform. So this is different waveform. This is square wave. So we can also change its, and this is ramp signal. This is also changing. So we can change also its frequency, and so on and so forth. So we can change the frequency at both the channels, and we can check the other signals at CRO. This is changing, so we can change the frequency from here also. As I have said, the function of this is 10. So as we increase the frequency, and when we press this button, so it should reduce 10 times. So the time period should be increased 10 times, and the frequency will be reduced by 10 times. So as we press this 10, so the frequency has been reduced by 10 times. You can see. So this is the function of this button. So now we will see how to measure the voltage and frequency on the CRO for any kind of waveform. So this is sinusoidal waveform we have applied from the signal generator. It is having some amplitude and some frequency. We can change its frequency from here also, from this knob. Okay. Now we can measure its amplitude and frequency of this generator. So now for this we can see there are some divisions. If we down it, So this display is being divided into two parts. One division. So this is vertical division. This is horizontal division. So it is being further divided, subdivided into 5 parts. So this one division. This is showing one division. This big division is one division, and it is further divided into 5 parts. So this will be showing 0.2. This is 0.4. This is 0.8. 0.6, 0.8 and 1. So this is total one division, and subdivision is showing 0.2 division. Likewise for the case of horizontal division also. So this is showing this is 1, this is 0.2, this is 0.4, 0.6, 0.8 and 1. So this will be showing one division. Now we can count the number of divisions. So this CRO we have to fit on the screen. So if it is bigger, then we have to fit on the screen. So this is, let's say we fit it. So this is now we can count the number of divisions. So this is showing one full division, 1, 2, 3, and this is 3 point. We can horizontal shift it 3.8. So the total number of division in peak to peak is 3.8. So we have to write it. So number of divisions. So this is for amplitude measurement. So number of divisions we have calculated. This was 3.8 division. Now we have to check the voltage per division. So voltage per division now is set at 1 volt. So we can now write it. So voltage per division is equal to 1 volt per division. So now we have to multiply both this. So the amplitude peak to peak will be given by the product of these two. So this is number of divisions multiplied by voltage per division. No, the number of division was 3.8 division. So 3.8 division multiplied by 1 volt per division. So this is division in denominator. So this will be cancel out. The unit will be cancel out, and you will be getting 3.8 volt. And this is peak to peak. So amplitude peak to peak, peak to peak. So next we will measure the frequency of this signal. So for measuring the frequency of the signal, we have to measure in the number of divisions in one full cycle. So this is, let's say I'm showing here. So from here we can start, and this wave is starting from here, and it is the one cycle is completed at this point. So we have to count the number of division in one full cycle. So this is from here, so we can count. This is 1, 2, 3 and 3.4. So approximate 3.4 divisions are coming in one full cycle. So we have to write it, number of divisions for frequency measurement. So we can write it, number of divisions equal to 3.4, and this is showing milliseconds. So we have to write it 3.4 divisions here first of all. So 3.4 division, and next the frequency, the time per division. So time per division is showing here. So this is set at, this now is set at 0.2 millisecond. So we have to write it, the time per division base, this is equal to 0.2 millisecond per division. So now you can multiply to get the time period. So time period can be obtained from the multiplication of these two. So number of divisions multiply by time per division. So division cancel, and we will be having only time. So this will be 3 point division multiplied by 0.2 millisecond per division. T equal to 0.68 millisecond. So we can calculate now frequency. So frequency F is equal to 1 upon T, that is equal to 1 upon 0.68 millisecond. So this will be equal to 1000 upon 0.68, that is equal to approximate 1470 hertz. So frequency is equal to 1470 hertz. So in this way we can calculate the frequency of the waveform which is on the CRO. So now that is, we have learned how to calculate the amplitude and frequency of the waveform on the CRO. Thank you.